In this video, we'll be looking at another method of factoring, and that is our method of factoring by grouping. For right now, we're going to know that we want to factor by grouping because they're going to give us some markers. They're going to give us a 4-term polynomial for one thing, and when we look at that 4-term polynomial, all 4 of our terms are not necessarily going to have a greatest common factor, but we might notice that pairs of those terms do, which is going to mean that this is a good candidate for factoring by grouping. And so when we factor by grouping, we are looking at pairing up items and then seeing if when we pair up items, we end up with sort of this odd common factor like we saw in a previous example where we had a binomial as a greatest common factor. We're going to use that here as well. So for example, if we have something like x to the third plus 7x squared plus 2x plus 14. On their own, these 4 terms in this polynomial do not have common factors. These 3 all share an x, but this one does not. The 7 and the 14 are divisible by 7, but 2 and 1 are not. The 2 and the 14 are divisible by 2, but the 7 and the 1 are not. So this is not something I can use my greatest common factor method on. But when I look at these 2 terms here do have a greatest common factor. They share a variable term for their greatest common factor. And these 2 terms here are also going to have a greatest common factor, in this case of 2. And so we're going to use our GCF method, but on pairs of the polynomial terms rather than on all 4 of the terms in the polynomial. So between these 2 terms, they have a greatest common factor of x squared. So I'm going to use that as their GCF. When I divide that x squared, again with that little monomial division, out of each of those terms, x cubed over x squared just reduces down to x. 7x squared divided by x squared becomes 7. So I have this result right here of factoring these 2 terms with the greatest common factor of x squared. My next 2 terms have a GCF of 2, and that GCF is going to be a positive 2 because the leading term between these 2 terms is positive. So to denote that positive 2, I'm going to write plus 2. I'm going to again set my parentheses because I'm factoring out a GCF from these 2 terms. I'm doing that little monomial division again. 2x over 2 just reduces to x. 14 over 2 reduces to 7. So now my polynomial, because I did this GCF method for pairs of the terms, looks like x squared times the quantity x plus 7 plus 2 times the quantity x plus 7. And if we've done everything right, this should happen over and over for us, that when we get to this step, this bigger term here that is kind of a mess of 2 factors, and this other bigger term here of 2 factors, they're going to have a common factor. Whatever's in the parentheses should match. And if it doesn't, we've probably done something incorrectly in the previous step. But here they do match. And so we can use that x plus 7 quantity as a common factor for this term and this term. So we'll pull it forward just like any other GCF. We're going to divide the quantity x plus 7 out of each of those terms. We're going to start another set of parentheses so that we can see what's left over when we do that division. Here, x squared times x plus 7 divided by x plus 7. These 2 quantities cancel, so we're left only with an x squared. And here, again, this cancels and leaves me only with that positive 2. So I have this factorization right here of x plus 7 times the quantity x squared plus 2. And just like before, if we weren't sure that we had done everything right, we could recombine these things through distribution, and if we do, we should get the same exact polynomial that we started with. If we don't, that means we factored incorrectly. But if we do, that means that this is the factored form of this simplified version of the polynomial. So let's just say we check for argument's sake. X times x squared would be x to the third. X times this 2 would be positive 2x. 7 times x squared would give me 7x squared. And this 7 and this 2 would give me 14. Now my 4 terms are not in order because I did not list them from highest degree to lowest degree, but the 4 terms that are present do match the 4 terms that were present in the original polynomial. And if I clean this up and wrote it in order, x cubed plus 7x squared plus 2x plus 14, it would match exactly with the original polynomial we started with, which means we did everything right for our factoring. Again, this is not a required step. It's just letting us know that we can always check if we want to. But this is our goal, is to have the factored form. In this next example, I gave you 4x to the third minus 16x squared plus 5x minus 20. Again, when I look at all 4 terms together, they do not have an overall greatest common factor, but pairs of them do, so I'll again be using my factoring by grouping method. So for these 2 terms, 4x cubed and 16x squared, they both have a common factor of 4x to the second power, so I will write that as their greatest common factor. And then I'm going to go through and divide each of those terms by that 4x squared again. 4x cubed divided by 4x squared should leave me with an x. 16x squared divided by 4x squared should leave me with a 4. So I end up with 4x squared times x minus 4 to factor these 2 terms only. When I go to these 2 terms, they are both divisible by 5. So 5, which is positive in this situation, is going to be my greatest common factor. And again, I'll write that as a plus 5 so that I don't forget that my 5 was supposed to be positive. And then go through and again do that monomial division. 5x divided by 5 would give me an x. 20 divided by 5 will give me that negative 4. So I have this. And again, we have that situation where I've got this sort of oddball looking term and another oddball looking term, where they have these common factors of binomials, in this case x minus 4, and they do again match, which should happen every time we factor by grouping. So I'm going to pull that x minus 4 binomial, as the GCF of these 2 big terms that I have now. When I do that, this quantity divided by that x minus 4 leaves me with a 4x squared. This quantity divided by x minus 4 leaves me with a positive 5. So this would be the factorization of the original 4-term polynomial they gave me. Lastly, I gave you this example, 2x to the third power plus 18x squared minus 3x minus 27. Again, all 4 terms do not have an overall GCF, so we know we have to factor by grouping. So we'll go to this pair here. These 2 are both divisible by at most 2x to the second power, so I'll write that down as their GCF. And then I'll go through and I'll divide that 2x squared out of each of them. When I do, this drops down to a value of x. This one becomes a positive 9. For these 2 terms, they have a common factor of 3, but these 2 terms as kind of a standalone polynomial makes this one the leading coefficient, and it is negative, which means I can't just take out the positive 3, I have to take out a negative 3 as the GCF. And so to write that, we're going to write a minus 3 there so we don't forget we took out a negative 3. And so these are going to both be divided by this negative 3. So in the parentheses, negative 3x divided by negative 3 is going to be x. Negative 27 divided by negative 3 is going to be positive 9. And so again we see that the quantities, or these binomials in the parentheses, match each other, which means now this binomial gets to be our greatest common factor for the terms that are left in this polynomial. So we're going to pull that forward as a greatest common factor, x plus 9. And when I do that little division of it out, I'm left with a 2x squared on the first term, and I'm left with that minus 3 on the second term. And so this is the factorization of the original 4-term polynomial they gave us. I hope that helps. Let me know if you have any questions. Thank you.